Okay, so now we try to look into the solution from the removing empty rows and columns. What's going on? Okay. Challenge. So, right, so the question was to write a function that removes the rows and columns with all zeros. And we can use here the numpy all function to apply it to a condition. The condition asks, hey, where is my data 0? And it looks in a particular direction. Now let's take this apart step by step. So first the condition. So we have data, and where's data 0? We see, so here this is false because we have 1 and 2. Then we have a whole row of truths, right, because they're all zeros here. And then we have false again. Now numpy all, right, basically asked if all of these conditions are true. No, they are not. For the whole matrix, right? But now we can say, hey, we actually want to distinguish between rows and columns. So let's see what's happening. So for axis 0, we see false, false, true. And if we copy for axis 1, then we get false, true, false. Because, well, axis 0 goes from top to bottom, right? So we check 1, or that is false, so we get false. Next column we can go to, right? Again, we start with a false, so everything with false. And the third one, well, yeah, this is true, so true. Next one, true again. Next one, true, so all of them are true, right? All. And therefore we can then collapse the whole result to be true. So for axis 1, we don't go from top to bottom, we go from left to right. So we get a false, right? Forget. Next row, true, true, true. So a second element here will be true. And the last one will be starting with a false, so are all 0. No, they are not false. Okay, so with this, right, we ask again, what are our data? Right, so we now ask for the rows it should be. So there, right, we only return the true value, right, and that would be, just now we saw it very nicely, the second one, but the second row is all 0. Okay, but the question actually was to select those that are not 0, but now we have selected all that are 0. So what we need to do is to invert the true to be false that we use with the tilde. Right, so the tilde basically negates or makes it the opposite, and not really the opposite, but puts it a bitwise flip, so to say, of the trues and false. Let's look into this. True, false, true. Enter. We get true, false, true. And the tilde operator, oops, it's a bitwise operator, so we make it an array, right? And that becomes false, true, false, which is the opposite. Now, in principle, we can get the same with not, but we need to use a list comprehension for that. So here it will be not I am same. Okay, so for the row selection, it works when we apply the same syntax. Now for the column selection, that will not work because it's a two-dimensional array. So we need to follow the indexing slicing notation of rows and columns, right? So here we need to have a segment index, for example. Okay, so you see in this line, we select these two columns, and in this line, we select these two rows. Well, and their common intersection basically will have no zeros. So what we need to do is we need to do one of the selections, update our data, and do the other selection, right? Update the data. Right, and this will give us the desired result. Now, everything in a function, right? You copy these two lines that carry basically most of the, well, all of these operations. You give start a function definition, give it a function name, provide the data object, right? The operations here, and return the result. So we reset our data. Execute. We check the data before we apply the function. We apply the function. Done. Easy.